Hi, I'm Jonathan LaCour. I'm the Chief Technology Officer for Mission, and I'm here in Chicago for the AWS Summit. And I'm here to speak actually in the Developer Lounge on a really fun topic. We find at Mission that people often have trouble grasping all of the different things you can do with the amazing power of AWS. So I'm speaking about kind of a fun thing, a connected barbecue grill and smoker. I'm going to be using lots and lots of different AWS services to really show the power of the cloud in kind of the funnest way I could think of. See all the heads looking up from your phones at the same time. That was pretty amazing. I almost wanted to get that on film. We should do it again. Welcome to the most important talk of your day. Very much an enterprise-grade solution for barbecuing. I thought I'd lighten up your day a little bit, but talk about some really cool technology along the way. So my name is Jonathan LaCour. We'll do intros in a second, but let's talk about what we're going to be discussing. We're going to talk about barbecue. I'm going to break it down for you. I'm from the South, okay? Mississippi and Louisiana and Georgia are in my past, and so barbecue's in my blood. I'll give you a little quick education on that. Then I'll introduce you to the greatest domain name in the world, pigemojifireemoji.ws. Yes, that's a real website on AWS. And we'll talk about how I connected my barbecue grill and smoker to the cloud. Smoking in the cloud. I'll show you the architecture. I'll do a deep dive. And while this is a kind of a silly and fun talk, the technology and all the architecture I'm using, I've used very similar architectures for real customers solving real problems, okay? But it doesn't always have to be boring. So first of all, hi, I'm Jonathan. I'm the CTO at Mission. Mission is an LA and Boston-based AWS partner. We do consulting and managed services. Talk about that more in a second. I'm a technologist, I'm a programmer and engineer, I'm a nerd, and I love barbecue and bourbon. Being from the South, that's what you get. We're here to help our customers architect, migrate, manage, and optimize for AWS, okay? That's all I'll say on that topic. Let's get to the important stuff and jump into the fire. So as I mentioned, I come from the South, Georgia, Florida, and Mississippi, and when I'm zoomed in on a good pulled pork sandwich like this, it makes me think about the best parts of life, right? This is life, this is joy, this is family, this is friends. Where I come from, having people over for barbecue is a ritual. It's an important thing, like going to church on Sunday for some people. And this is my smoker. There are many like it, but this one is mine. You'll notice that there's a star on that. Technically, that's not my smoker. It's the same smoker I have, just in a much prettier place. So I took a picture of that one instead. So it's called a big green egg. How many people have heard of a big green egg before? Yeah, all right, good marketing for them. They're a Georgia-based company. Let's talk about the science of smoking and how it works, because that's all gonna be important and to how we built this thing. So the Big Green Egg is this big ceramic grill and smoker. It actually comes from a Japanese style of cooker called a Komodo grill, or Komodo grill. And they're thick, weighs a ton, and it has two openings. One on the bottom here, which is a vent where fresh air can enter, go over the coals, the charcoal inside, and the wood, and exits the top, and you can control the size. And so you put your charcoal in, and what I used to do is, if I was doing, let's say, a 12 to 14 hour smoke of a Boston butt, which is a pork shoulder, to make pulled pork, I would have to, sit outside with a beer or bourbon and fiddle with the controls all day and all night till everything, it would hold it pretty well within 10 to 15 degrees, but it's a lot of work. And as with anything in life where an engineer has too much manual work to do, I wanted to automate. So I'm going to introduce you now to this little Internet of Smoking Things device from a company called Rock's Barbecue. It is called the Stoker, and it is a little MIPS controller running Linux, and it has a bunch of ports on it where you can plug in temperature thermocouplers, which can tell you the current temperature of either the ambient air inside the smoker or in the meat that you're cooking, or whatever it is that you're cooking. In addition, there's this little CPU fan. That's from back when we used to have these things called servers, you might remember. You probably have some in your laptops. Actually, most of you probably don't. But this attaches to the bottom and feeds air in. The ambient temperature controller sits inside and measures the temperature. You set your target temperature, and it'll keep it that way for 20 hours without opening the lid, within plus or minus 2 or 3 degrees, which is pretty amazing, right? So what did I build exactly, and why? Well, I wanted to scratch my own itch. So yeah, I built pigfire.ws. And yes, you can only get emoji domains in like 2 or 3 TLDs, and .ws is one of them. I also have one that is for my Twitter name, Clever Devil, and it's a little light bulb and a devil emoji, which is nice. So what I have is I have real-ish time monitoring of cooking, okay? I know the current temperature of both the cooker and what is cooking inside it. I can see the target temperature. I know whether or not the blower is on or off, so whether or not it's feeding air into the cooker. And I have time-lapse graphs and charts and alerting, and I also have summaries of historical cooks and charts, Twitter integration. So the website actually tweets out every 5 to 10 minutes, here's the current status of what's going on. And it even can be controlled by my voice. So you can ask Alexa, what is the delicious data? And it will tell you what's currently going on in my grill. And I use the Apple thing at home. So I can tell Siri to set the target temperature of my grill to something, or what's the current temperature of the meat in my grill, and it all works. So here's what it looks like on the front page. This is a current status page. So you can see kind of little charts, real-time-ish time, that show what the current temperature is, and over time. It's really fun to watch how certain types of things that you cook hit what's called a plateau, and then you hit that temperature and water starts to evaporate and it stays at that temperature and eventually rises up again. I have a history page as well, so you can go through and see all the historical cooks, including kind of summary data, what the minimum temperature was, what the maximum temperature was, the total duration, all that good stuff. As I mentioned, it's integrated with Alexa and HomeKit, so here it is showing them as devices in my iPhone on my Home app, so I can talk to my HomePod. I have all this wired up to Alexa as well, so I can do the same thing there. It's pretty cool. So let's talk architecture for this crazy thing that I built. This is the first architecture diagram you've ever seen that has a barbecue grill on it, so I'm pretty proud of that. And that's me. I'm this shadowy figure here. So I have my Stoker device here, right? And it actually talks to, I have a little home server, and by little I mean enormous, but that's not the point, that I have running in my house for storing a lot of stuff and backups for family things. And so I have a little agent that I put on there, and it communicates with this device. When it sees it come online, it wakes up, it gets a well-known name on my network, and so it connects to barbecue.lacour.local and knows where it is. And it starts to get data and sends it up to the cloud. How does it do that? We're using the API gateway and talking to Lambda. Chose not to use AWS IoT for this particular solution because MQTT wasn't really a good fit for this particular workload, and frankly, I just wanted to do it this way. More fun for me. All of these are talking to Lambda functions behind the scenes, okay, and ingesting the data into an S3 data lake, which I have connected to QuickSight as well, so I can actually go through and do some more, detailed reporting and analytics. And Athena, which enables me to actually run S3 or SQL queries against my S3 data lake, right? So you can imagine you could swap this out here for devices on a manufacturing floor or a connected vehicle, right? The architecture is pretty much the same. So let's go a little bit deeper. So I wanted to get a little creative with the names because engineers love to name things funny names. So the agent and web service are called Inhale, right? Get all the data in. So the agent runs here on it's a little Synology NAS, which is like a little file server at my house. And when the device comes online, it connects and it starts to pull from its API, a little REST API, REST-ish API, and I can fetch all the current, kind of telemetry from the device. And then the agent is kind of dumb on purpose. All it does is pull data when it starts to see it and sends it up to the endpoint that's configured. It has timeouts and it has sort of intelligent backing off, and if the device disappears, it eventually will stop sending data and just wait, right? And then the web service is a lot smarter. It knows when there is a cook that is active, like a cooking session, or when it hasn't seen data in a while. And it'll automatically provision kind of new ways to track a cook. So when data is flowing in, it associates that with the current active cook and stores it. And then it makes all that data available to consumers via a REST web service. So it is configured. So there's the agent, as I mentioned. Configurable polling and batching. So I got a little out of control on this a couple times and I'm trying to figure out how much data do I actually need. Turns out, if you send up too much data, it becomes problematic for a number of reasons. And you really things don't change that often, right? They change maybe every couple of seconds, right? So a good polling example might be every 5 seconds with a 60-second batching. So what it'll do is it'll poll the device every 5 seconds for 60 seconds, collecting 12 data points, and then it'll push that 60 seconds worth of data, that 12 data points up into the cloud, right? This is what the data looks like. I can tell you whether or not I'm on an alarm state, what the current date time is in UTC, you know, God's own time zone. The target temperature of the cooker in Fahrenheit, the current temperature of the meat, and target temperature, whether or not I'm alarming, meaning have I reached the target state, and the current temperature of the cooker, and whether or not the blower is on as a 0-1 state. It really should be true or false, but you know, that's my fault. So yeah, I'm running an on-prem, this is a hybrid environment, okay? So everyone's aware of that. So, see, I got at least one chuckle. I know my dad jokes are funny to somebody. So how is it built? Well, serverless is amazing. Lambda's wonderful, and you can write directly, you know, using Python into the Lambda kind of structure, and there are some good toolkits out there. Serverless framework is a great one. For this, I use something called Zappa. It's another awesome framework. It's Python specific. I love Python, been running Python since, gosh, 1996, 97. And so for me, Zappa was a great choice. And it allows you, if you already have a Python kind of web framework you like using, you can build a Python web service and then use Zappa to deploy it to Lambda, okay? And it does all the good stuff for you, wires it all together. It actually effectively generates a CloudFormation template, orchestrates everything, exposes it using the API gateway. You can even wire up certificates through Certificate Manager. You can also configure it to help you avoid cold starts, right? So it'll do a no-op operation on a configurable kind of time frame to keep your Lambda alive. It's pretty great. So the endpoints that I built out, an HTTP post for adding data points. We've already talked about that kind of batching mechanism. I have an HTTP GET, which says, give me a list of all the cooks, please. And then I can say, give me the details on the current one, or on a specific historical cook by its UUID. So I could come in here and say, give me a list of all the cooks, date, timestamp, some metrics around them, and a UUID. If I want detail, I can go in here and I can get all of the details, all the data points, whatever I want. And that is wiring up here into the API gateway, right? Which then calls Lambda functions. So let's talk about the first one first. Getting data in. We've already seen what the array, it's a array of JSON kind of objects, right? And inside each one represents a data point. I am in the web service formatting those in a very specific way to enable me to use AWS Glue, which is basically an managed ETL service, and then Athena down the road. And the way that those services like the data formatted is an object in S3, right, containing one line of JSON with no kind of new lines in it for each data point, okay? So I take each one of those batches and they become a single file, a single object in S3, okay? And I'm also kind of segmenting out the objects here, partitioning them, using the cook UUID, which makes it a little bit more efficient for querying later with Athena. All right, so it's smart, like I said, it provisions a new cookie UID if it's necessary, it has all the smarts inside. All of this is open source, although I haven't put it all up on GitHub yet, most of it is. So when you're getting a list of cooks, it's pretty straightforward. It tells you what the ID is and when it started, okay? So that way you can kind of pull out the cook you want. And when you want detail on the current cook, it'll tell you when it was last updated and when it was started, right? Along with the ID and some data. The data is an array of literally every data point. So if you have, you know, a long cook, like 12, 20 hours, you can end up with a lot of data, right? You can also fetch historical cook details. It's very similar. The difference is that you get a summary in the historical cook details as well, because now the cook is over. So I can do some calculations on it around what was the minimum and maximum temperature, what was the total duration, so on and so forth. All right, making good progress here. We have about 10, 15 minutes left. So the website itself, how did I build that out? So I picked an off-the-shelf CMS because I didn't want to spend my time working on that, right? This is a solved problem. Barbecue as a service is not a solved problem. So I use a CMS called Known. Known. And it has great support for syndication out to other services. So it already had a built-in kind of Twitter plugin to allow for syndication to Twitter, and it supports a standard API called MicroPub, which is a really simple publishing API. So that made my life easy. The agent talks to Lambda, Lambda then talks to the CMS, which then talks to Twitter, okay? It does all the hard work for me. And you can see here, as I'm posting them out, they end up posting out here on my John's Big Green Egg Twitter account, including, you get the photos after the fact. That's a porchetta, which is a rolled pork belly. Yeah, it is as good as it sounds. So let's talk about Glue and Athena. Who has used Glue before? Wow, very few people. Okay, it's pretty cool. So it allows you to basically create this managed set of tables in your data catalog and map them into other data sources. So in my case, I have an S3 bucket, and I'm saying, hey, over there I have some data. It has this feature called a crawler. So you can go in and say, please crawl all of the data and look for common patterns and discover the schema, effectively, of this table. So I ran one cook, I ran the Glue crawler, it created a schema, I made slight tweaks, then I'm good. You can also have the Glue crawler run periodically if you have data that may evolve over time, and it can do things like updating your schema and so on. Then what you get is, from Athena, I'm literally writing SQL, just ANSI standard compliant SQL against data in S3. Pretty cool. And you can even do pretty sophisticated things like views, and it's great. I'm a big fan of Glue and Athena. So here's an example of once you run the crawler, kind of what the schema looks like, and you can see it's figured out all the parameters and the paths inside the JSON object, where it lives in the bucket, kind of the data types that are associated with each column. And then I did build out, actually I had our lovely intern at Mission build out the Alexa integration. He had a lot of fun doing this. Great opportunity, intern at Mission. You get to work on fun stuff. And you can ask, hey, give me the delicious data, and you can see it goes through, it talks to the web service, gets the data out and reads it to you. Thank you, Alexa, for being awesome. So again, reviewing the architecture diagram one last time. This shadowy figure goes up to this barbecue grill, gets going, has a Stoker connected barbecue controller that talks, or is talked to by an agent that runs on my home server. It then communicates via Lambda functions, via API gateway, a REST web service, with a data lake, storing data, fetching data, doing all the things that it wants to do. The Lambdas talk back to the website, which is actually hosted on an EC2 instance, and it talks to Twitter. And then Alexa and Siri talk through the same API gateway Lambda functions to activate the voice side. So that's what I've built. I hope it was enjoyable. The way it works is you're basically feeding oxygen to the coals, and that more oxygen means more fuel for the fire, and it'll burn hotter. And when you want it to stay the same temperature, you just turn it off, right? And it just watches. And it's funny when the fan makes a very slight noise, and so you can hear it, spinning a little bit. It's pretty fun. So basically, the agent is a Python-based. Would you mind handing that mic to me real quick? Thanks. The question was a little bit around the mechanics of how everything is wired together. So the agent that runs on my home server is a Python script, effectively, and just running 24 hours a day. And it uses HTTP to talk to the device. So if it's not online, it just times out and waits, right? And then it fetches the data, and then it makes HTTP calls up to the API gateway, which then calls a Lambda. Does Glue talk to Athena? I guess it depends on what your perspective is, right? The way I think of it is, Glue is the data catalog, it's the ETL. It manages kind of the creation and management of that catalog of data tables. Athena can query those tables. So it's not so much necessarily that they talk to each other, it's more that Glue does one part and Athena does another. You do have to, yes. Now you can actually query S3 directly from Athena without creating a Glue table, but there are some good reasons for creating the Glue table, just for your schema management and there's other reasons. Challenges on the project. The customer was a real pain. He kept on getting distracted and just eating all the meat, right? Instead of getting work done. No, honestly, the biggest challenge for me was, I really wanted it to be, I knew I could have used something like Dynamo or put everything in a traditional database, but I really wanted to dive deeper into data lakes. And so it was sort of this, performance and storage and how much data to store, that turned out to be quite a lot more of the work than I thought it would be. And just finding that happy medium. Like, you don't need, it's good to have lots of data, but you don't need so much data that it becomes harder to extract signal from the noise, right? So that was the biggest challenge. What's next? I have a sous vide at home, and it has an API, so that's coming next. I just need to come up with the right emoji domain for sous vide, so if you have suggestions, that'd be great. The total cost to run it with around 10 historical cooks right now is around $1.08 a month or something of that nature. That doesn't include the EC2 instance for the website, okay? That's more expensive because, you know, it's got a server. Evil servers. Yeah, it's pretty inexpensive. All right, thank you everybody. To learn more about Mission and how we can help you achieve your goals in the cloud, visit us at missioncloud.com.